In our last two videos, we talked about two measures for the center of a data set. Where is the middle value? Now we're going to talk about measures of spread or variability. And the very first values that we use to measure spread are variance and standard deviation. Variance and standard deviation. The equations are related. We're going to start with variance. And this is going to be a little bit weird. These equations are freaky. Please don't panic. I am never going to ask you to calculate these by hand. The goal is to understand what they are so that you can understand what your calculator is spitting out when we talk about them. Okay, so variance. Why am I having a little brain fart right now? I don't know. So our variance, we're going to use Sx for standard deviation. Variance is the square of the standard deviation, so it is Sx squared. And notice that's an English letter, so both of these values are sample standard deviation and sample variance. I'm not going to go over the formula for the population standard deviation because we don't ever calculate it by hand. If you are curious, it is in your book in section 2.7. For the variance, what we're looking at is the average distance from the mean for each data point. And you'll notice variance is squared, so it's technically the square of that distance from the mean. So to calculate variance, the very first thing we're going to do is for every data value, I'm going to take my data value and I'm going to subtract the mean from it. And that quantity, data value minus mean, is called the deviation. How far is it from the mean? What is that deviation from the measure of center? We're then going to square that value. And the reason we square it is if my data value is less than the mean, I get a negative answer. If it's greater than the mean, I get a positive answer. And my next step is to add those numbers up. And if half my numbers are less than, half my numbers are greater than, all of those numbers are going to cancel out. I'm going to get a 0. That's not helpful. So we look at, instead of just the sum of the deviation, we look at the sum of the squares. That gets rid of that issue of values canceling. We're then going to divide that by n minus 1. N minus 1, sample size minus 1. It kind of looks like an averaging process. I'm adding a bunch of stuff together and then dividing by approximately how many things there are. It's a little convoluted because we have to worry about those sign differences where we didn't have to worry about that with the mean. The standard deviation is the square root of the variance. So it's just that fraction square rooted. You can think of it as undoing the square that we did to get rid of that sign issue. I squared the deviation. Now I'm taking a square root to kind of undo that and get a sense for the average deviation from the mean. How far from the mean is my average data point in my data set? On the off chance that you are unfortunate and all of technology dies and you have to do this by hand, or you are teleported back to the 90s when your calculators wouldn't do this for you, you should make a table so that you can do each step of the calculation separately. First, make a table with your x values. Your next column should be the deviation, x minus x bar. Your third column should be x minus x bar squared. Because once you have that column, x minus x bar squared, you add down that column to get the top of your fraction. And then you just divide it by the sample size minus 1. So on the off chance you're doing it by hand, a table is helpful. So x minus the mean, x minus the mean squared. That would help you calculate. However, we are in 2025, so we don't need to do this by hand. You're going to find the standard deviation on your calculator with the exact same commands we used for mean and median. 1var stats, 1var stats. If you are asked for variance, you need to work backwards because your calculator is going to give you this. And to undo that square root, you square it. So to get from standard deviation to variance, you need to square the standard deviation. Multiply it by itself. We're going to go ahead and find the standard deviation for our data sets from the last couple examples. So I'm going to go ahead and pull up our calculator. And I'm going to show you a nice trick for when I'm working with multiple sets of data. So when I go stat enter to get my data in a list, you'll notice that the data from question 2 is already in there. I don't want to have to clear that out only to retype it. So what I'm going to do is I'm going to put this list for problem 1 in list 3. That way I have all of my data for both problems in the calculator at the same time. I don't have to delete or remove when I know I'm going to need it again in a little bit. And I missed a data point again. Oh, I missed a 9. 10, 9, 4, 4. There we go. I keep missing 9s. All right, so the data that I'm interested in, if I go back to the top, is in list 3, L3. So when I go to do stat 1var stat, I need to tell it that my data is no longer in list 1. It's in list 3. And I didn't mean to delete that. So second 3, because it was raw data, frequency list should be blank, and I'm going to run that command. And I'm going to scroll up, and you'll see that the fourth value is labeled SX. That's my sample standard deviation. So SX equals, and I'm going to round it to one place past the decimal. So 3.3. 3.3. We're going to do the exact same thing for our paired data. So looking at my list menu, my data values are in list 1, my frequencies are in list 2. So I go stat, maybe, calc 1var stats, data's in list 1, frequencies in list 2. I run that command and scroll up, and I can see that SX is 1.02, which is going to round to 1.0. So for this data set, the average data point in this table is 1 point away from the mean, meaning the data is clustered fairly close together, which makes sense because the range is very small, 0 to 3, and most of the data is between 1 and 2. So I would expect a small standard deviation or a small spread. With my list of raw data, my smallest is down at 1, my biggest is up at 10. There's data spread throughout that range, so I expect a bigger standard deviation because my data is more variable. All right, if you have any questions on how to find the standard deviation or variance, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.